Okay, here's an example of a complicated, but not too hard, solution for a general solutions example for a trig equation. So I've got the equation sine 3 bracket x minus pi over 3 close bracket plus a half equals 1. The hint here is obviously I've got pi over 3 there, so I know I'm going to work in radians. So step 1 for my instructions was just to solve it as normal for a trig equation. So the first thing I'm going to do is move that a half to the other side, so it'll become negative a half. So my next line is going to be sine 3 brackets x minus pi over 3 equals a half. The next step in solving the equation is I'm going to get rid of the sine, because all the rest of the stuff is within that sine function. So inverse sine. Now hang on a minute, I've got an angle of a half. Inverse sine of a half. That makes me think I might need to go and look at my exact values triangle. And oh yes indeed, if I look at that, I can see that to get a half with sine, I can work out that the angle must be pi over 6. So the next line of my equation then, sine is gone, I've got 3 bracket x minus pi over 3 equals pi over 6. Okay, stop. Remember my second instruction said, as soon as you've inverse sine, cos or tan, you stop. So I'm going to stop and move to my general rule for sine. So x equals, or alpha equals, I'm going to substitute in what I've got on the left hand side here. So I stay with the 3 x minus pi over 3 on the left. But now the right hand side, I use my general equation, and I have now n pi plus negative 1 in brackets to the power of n times by whatever my first angle was, which now I know is pi over 6. So that's kind of my general solution, but obviously the left hand side there I want to be x equals. So I'm going to tidy it up just like solving a normal equation. So the first thing I'm going to do is divide everything by 3. So I've now got x minus pi over 3 on the left, and on the right hand side I've got n pi over 3, and the second part is going to be divided by 3. So to do that I'm going to take my pi over 6, and that's going to become pi over 18 because I've divided it by 3. Finally, I need to add that pi over 3 to the other side, so I get x equals n pi over 3 plus negative 1 to the power of n pi over 18 plus pi over 3. And that's all I need to do. That is now complete. If I wanted to find any values, I just substitute in integers for n, and it will give me all the possible solutions.